All right. And as I announced yesterday, for your programming test number 2, it has been postponed to next Tuesday, November 15th. The same time, the same policy, the same coverage. And hopefully you guys can take advantage of that. We'll see. Okay. For your lab number 3, just don't forget it's due today at 2 p.m. Just don't miss the submission. It's being set to close automatically, so make sure you submit in time. All right, so today is going to be a bit heavy because we're going to dive into the notion about static type versus dynamic type. So I'll try to get slow, but as we go over some principle and sometimes example, you will see there might be some repetition I will keep mentioning, but I think that's really important. It's a difficult subject. We'll see. Okay, let's start with something gentle. And a recap from what we achieved from Monday. So we talk about the student management system example, and we talk about 2 design attempts without the inheritance. And we talk about design principle like a cohesion and single choice principle, right? That's what we did. And then we move on to talk about the visibility, about using different modifiers. And also we talk about this 3rd design attempt, which will use inheritance feature. Notably, you can see we got extends keywords over here in all the subclasses. And also we got the super keyword over here for us to reuse the code that's inherited from the parent class. That's what you guys learned last time. Right? That's something we assume. And let's now just go over one slide, which will build the foundation for today. Okay, so that's the architecture that we went over. And the terms about parent class, superclass, child class, and subclass, they're rather straightforward, right? Very quickly. So you can see this student class will be the parent class or superclass. And these 2 classes over here, which extend this class. So these are called the subclasses or child classes, right? Straightforward notation. What I want to go over carefully is about this slide here, about code reuse. You can think about this as more about summarizing the first aspect of inheritance. Once we understand about code reuse, we're going to dive into typing using data type. That's going to be more demanding from your brain power. We'll see. All right, so inheritance in Java, use of extend and use of super keyword allows you to define the common attributes and methods in a separate class. In our example, it is in the student class, right? Let's just highlight it very quickly. You can think about almost everything we define in the student class. You can see these are the common attributes. And you can see the part about the constructor code, which we can also reuse. And also, you can see this method over here, and also this method over here. So these are all the common parts that are actually shared by the subclasses, right? Let me just note that. So all the green ones are the common code inherited to all subclasses. Of course, if you decide to have just another subclass later, maybe call it international student, you will also inherit everything from here, right? The same principle. That's the first bullet point. And we will define the so-called extended or specialized version of the parent class, which, well, there are several things we can do. Number 1 is going to inherit the definition for all the attributes and methods. What does that mean? That means, for example, here you can see in the resident students class, we didn't actually explicitly define register method because that one has been inherited automatically to this class. So it's implicit. So we can definitely use it if we want to. Also, the get tuition is also inherited to this class over here. But in this case, we decide to modify its definition or override its definition a little bit, right? Just notice the difference. They are all inherited. And if you go back to the slides, it's gonna, for example, the name, courses, NOC, right? You can see these attributes over here. Name, register courses, NOC, they're all inherited to both subclasses. And then register method, which I also pointed out to you, and also the base amount calculation. So the get tuition here is only calculating the base amount. That's also inherited to here. You can try to build on top. That's called overriding. Okay. All right, and then, so this means code reuse. And we can really satisfy the single choice principle as we observe as a weakness in design attempt number 2. Right, and this is also very important. This bullet point is especially important. You may define new attributes and new methods if necessary in the subclasses. Why? Let's take a look. Well, in the bullet point, you will see here. Let's say over here, if you take a look here, you can see premium rates and also discount rates. Due to the space limits, I didn't really have that method here. I'll just write it down and I'll show you how you can find them. So these two are the new attributes. The discount rate is a new attribute that's defined in the non-resident students. And premium rate is a new attribute that's defined in the resident student. And what do I mean by new? That means the premium rate is not really inherited from the student class, but it's something I add in addition to it. All right? This is not inherited from the parent class. And you can define new attributes or new method as well. Let me just put one here. Also, there's another new method. Since in this case, we talk about premium rate for the resident students, we got another mutator called set premium rates. Right? Let me show you how you can find it. If you go to the code I made available to you, if you go under the package called with inheritance, if you go to, for example, resident students, you will see the resident students is a subclass of students here. And you can see we got a new attribute premium rates. We also got a new method, set premium rates. Right? That's how you can find it. Okay? And what's really important about the new attributes and new methods? Why are they important? They are only available on the subclasses, but not in the parent class. Let me write it down explicitly. This is a very important concept over here. New method and also new attributes. Right? So these two. This one here and this one here. Right? I'll put it here. New attributes and new methods declare or define in subclasses are not available in parent class. Let me just make it more explicit to you. For example, let's talk about this student class, which is a parent class. If I say students, S will be new students. Let's say, with some name maybe. Now, can I actually say S dot set premium rate? That's an important question, to be 1.25, for example. Is this line valid? Right? It shouldn't be, because S is pointing to some student objects, and the student class does not have the premium rates. It's only available in the subclass. All right? Just keep that in mind. It's a very important concept called expectation, which I'll elaborate much further a little bit later. You can think about the set premium rates over here. We call it outside the expectation. Of students. All right? Okay. Let's now take a look further. New attributes, new methods, and then, of course, you can also override or redefine the methods that you inherited from the parent class. You can see specifically, here we got the get tuition over here. Let me just use a different color here. You can see we got get tuition here. That's defined in the parent class. We can choose to override this method over here. So that's one, and this is another one. So we are making some changes to it. Okay, so this is about overriding. Overriding the inherited method. Okay, one more emphasis. Compare the register method and the get tuition method. The register method is inherited to both subclasses without being overridden. On the other hand, the get tuition method, at the same time, on the one hand, it is inherited to both subclasses, but at the same time, it's also overridden. Okay? All right, hopefully so far it's still sensible to you. So register over here, in this case, it is inherited, but not overridden. It could be, but in this case, no, not overridden. But what about the get tuition here? The get tuition here, it is inherited and overridden. And overridden. You can see I'm trying to just summarize what we did last time on Monday, but I'm trying to add a little bit more information to it, especially what I said about expectation is something we have to worry about very often in the later lecture. All right? Guys, up to this point, any question? Are you okay with it? All right, if you follow so far, that's a good sign. Before we get to the more confusing bit, if that's the first time you learn about inheritance. All right? Okay, how do you visualize the objects when you actually got inheritance? Very easy, okay? Very similar as before. Okay, let me summarize the architecture very quickly, right? You will see this diagram here very often in the later example. So we got students, we got resident students, we got non-resident students. For students, we got name, courses, number of courses, and also we got constructor, register method, and get tuition, right? So these are what's available in a parent class. In the resident student subclass, what we try to do was we try to define some new attributes or methods, like premium rates and set premium rates. Similarly, for the non-resident students, we got new attributes, discount rate, and new method, set discount rate. Finally, for the get tuition method, we got overridden version. In resident students, by using the premium rates, and also in the non-resident students, by using discount rate. Okay? That's the architecture. Now, let's say we got this over here. Okay? We are trying to create S, RS, and NRS. Okay? We are trying to create 3 different kinds of objects over here. S is going to point to some student objects. RS will point to some resident student objects. NRS is going to point to some non-resident student objects. How do we visualize them, right? So the idea would be you ought to figure out what's the accumulated attributes inherited from the parent class. For example, in the case of students over here, that's the top of the inheritance hierarchy. What attributes do we have? We have basically the name, courses, and also number of courses over here, right? So that's why you will see for the student objects, you got name, courses, and also number of courses. That part is easy, okay? What about the case of resident students, for example? In that case, for resident students, not only that, you got name, courses, and NOC. They are all inherited. You can see this part over here is inherited from the student class, okay? This part here, inherited from the student's class. And you can see there's also one new attribute over here, premium rates. That's exactly what you see over here, right? So this one over here is the new attributes. You have to make sure when you draw the object diagram, you actually include all the new attributes as well at that level of the class. Otherwise, you might just lose track. All right, similarly, what about non-resident students? You can see we also got a discount rate, which correspond to the new attributes over here as well. So this page simply just tells you how you can trace the code by drawing the diagram, right? Pretty much the same as before. The only difference is you have to make sure you understand the accumulation of the attributes. Not only the attributes you declare at this level, but also all the attributes that's inherited from your parent class. All right? Are we okay so far? About visualization. All right? All right, and then let's go on. And that's about the visualization I just talked about. And This slide here is just about testing the 3 classes we had. That one there, we don't need to spend too much time. It turns out, okay? And when you study this particular test on the slides, this is what you have to pay attention to. Number 1, you have to make sure you understand why for the resident students, you got these 2 attributes. And for the non-resident students, you got these 2 attributes. You can see here, this is a difference, PR and also DR, discount rate versus premium rate, right? So these are the new attributes. So these are the new attributes declared in the subclasses. Right? That's really important to note. Apart from that, the way we actually create the objects, the way we set the premium rates, right, over here, will be just the same as the previous example, which I'll show you quickly. If you remember this example we did on Monday over here, right? Remember the testing code over here. The way things work are just the same. So we don't need to repeat that part, okay? There's only one more remark I would like to make. That will be a nice look ahead for later. I want you to pay attention to this. Take a look at this, and take a look at this. Resident students, they match, right? In general, they don't have to match. Let me highlight this line over here and then pose a question now. And you will find out the answer for later, okay? This is one line. What if we do the following? Rather than putting resident student here, oh, by the way, so far, you would think in Java, always the type and the constructor must be the same, you would think. No, not in general. What you could have written would be something like this. You might say, students, gen equals new, I'll just say RS for resident students, right? And then whatever name it is. You can see here, let's do comparison. This part here, resident students, that part is the same. But here, resident students, but students. So the question you want to ask yourself is, what will be the consequence of choosing one, but not the other? That's something you want to ask yourself later. We're going to see exactly what the consequence is later. Okay? Okay, and then, okay, good. Any question so far? Are we good? Okay. I would suggest that we do a little exercise over here. Okay? This will be the exercise we can do. I'm going to explain to you what the exercise is, and then I do have the hard copy of the exercise over here. If you really want to do the answer on the paper, you can now just feel free to come over and pick it up. Otherwise, if you want to grab a sketch paper, that's fine too. It's up to you. Okay? I'll put the hard copy here if you want to pick it up. Otherwise, you can just do from the screen. Either way, fine. Okay. Let's now see what the exercise is. It's a very important one. Okay? We are now moving to the more initially confusing bit, so be careful. Again, that's the hierarchy here. Students, resident student, non-resident students. All right? And let me highlight again. Name, courses, number of courses, so these are inherited to the subclasses. Of course, the method as well, for sure. All right? The green ones are inherited. And for resident students, we have new attributes and new method. And also for non-resident students, we got new method and also new attributes, right? Discount rate only belongs to non-resident students, and premium rate only belongs to resident students, okay? And now, let's say this. We got students, resident student, and non-resident student. We got 3 types over here. And if you recall what we said back in the equality lecture, I said before, whenever you try to declare a variable, the declare type over here is so-called the static type. All right, let's revisit that point. Now we're going to see the impact of the static type. You can see this part over here, this part here. These are so-called the declared types or static types. Declared or static types. I will use the term static type more often. Okay, static types over here. So that means S, RS, and NRS, they are of different static types. Okay? And if you recall what I said earlier in the equality lecture, the static type determines what methods or attributes you can invoke on the context objects, meaning that the static type over here and the static type over here determine that S and RS maybe invoke different range of the attributes. Okay? Let me start with you with one row. Okay. So here we only look at the static type. That's what really matters. Let's say for S, we want to say S dot. If you do the similar experiment in Eclipse, it's also going to show you the range of attributes or method you can invoke. But let's not do that on the paper. It's important. If I say S dot, there are different possibilities. It can be S dot name, S dot register courses, S dot number of courses, S dot register method, S dot get tuition, S dot premium rates, S dot set premium rates, S dot discount rate, and S dot set discount rates. So these are all the possibilities. Some of them may be invalid. You ought to know exactly which ones are invalid. Okay, you can kind of see what the issue is. Okay, so now I want you guys to think about just for this row. Based on the static type for S, it will determine whatever that's declared in the class, either explicitly or implicitly, can be invoked on this particular variable. Let's start with the students, which is easier. Okay, now for all these, are they all valid? Well, some of them are invalid. That's a question. Okay, how about I start with Ferris for this one? Ferris, go ahead. Okay. So what Ferris said was whatever that was declared at the subclass level will be invalid, meaning that we got discount rate. So we got discount rate here and also premium rate because they only belong to subclasses, but not this one here. All right. So that means S.name will be okay because name is declared exactly here. S.courses will be okay too. S.number of courses is also fine. S.register, defined here. S.get tuition is also fine. What about S.get premium rates? No, because premium rate is only defined in the subclass. And the premium rate is not declared in the student class. And remember, students, S has been declared as a static type, right? What about set premium rate? Similarly, also it cannot be. Okay, so these two are not good. How about discount rate? Also similarly cannot be good, right? Are we okay so far? If you already got lost, you gotta let me know. Things will get even more complicated. This is only a starting point. Guys, are we okay? Are you sure? Okay, I'll take silence as yes. I know you guys are shy. That's fine. How about second row? The second row goes like this. The RS we're talking about has the static type resident student. That means everything, including attributes and methods, that's either declared explicitly or implicitly. When I say implicitly, I mean they got inherited from the parent class. All those attributes or methods may be invoked upon RS. Marcus, go ahead. Yes, I agree. Okay, very good. Let's see the reasoning. That's exactly right. So since the RS was declared as resident students, which is over here, that means everything explicitly, which would be premium rates, set premium rates. and everything that's implicit, which is inherited from the parent class, 1, 2, 3, 4, 5. Okay? So that means we got everything from the parent class, and also everything that was declared explicitly in the resident student class, but not what we call the sibling class. You can see resident students is not the same as non-resident students. So these two are not good. Okay? Finally, the third row. Go ahead, please. NPR, exactly. Right? So now we talk about NRS, declared as non-resident students. In that case, everything explicitly, discount rate, separate discount rate, everything implicitly inherited. Exactly. That's right. So everything from the parent class and everything that was defined explicitly here. That's the table. Guys, are we okay so far? I'm going to use this table to summarize some important points, which is about expectation. Here. Think about this row over here. Sorry, yes, this one here. All the attributes and methods that you may attempt to call is called the expectation. Some of them might be valid, some of them might be invalid. Expectation, all right? Now, can you observe any relationship between the expectation I may impose on a parent class versus the expectation I might impose on subclasses? Is there any general conclusion we can make? At least 2 points I can say. How about I take you for one? Go ahead, please.
So generally, you can conclude that the child class will have at least as many methods and attributes as the parent class or more.
I like that. Let me write it down. Observation number 1, for each subclass, their expectation will include at least the expectation you can impose on the parents, at least, due to inheritance, due to extents. All right, that's number 1. Let me write it down, and then there will be a second point we also need to know. So number 1 is about this part over here. Observation number 1. Expectation, let me write a little bit more carefully. Each subclass expectation is at least as much as its parents. Meaning that there might be more expectation, but at least it will include what we can expect on the parents over here. You can see RS includes expectation from the parents, and NRS also includes the expectation from the parents. What about between siblings? That will be the second observation we have to make. Can we say anything about the expectation between sibling classes, meaning resident students and non-resident students? Can we say anything about it? Let me be more precise. The second observation we have to make is about between these two subclasses over here. Because RS is resident students here, and RS is the non-resident student, which is here. We call it a sibling, like a brother and sister. Right? In that way, can we say anything about the expectation in general? Can we? Parents, would you like to say something about this between siblings? I agree. Good. And can we say anything else? Beyond the parents' expectation, right? Very good. Let me write it down. Very important. So between the siblings, there are 2 things we can say. Number 1, they share expectation from their parents. They inherit. Sibling classes share expectation, or you can say inherit expectation from the parents. And number 2, which is about this point over here. What about beyond their parents' expectation? In this case, in general, we cannot say anything because you can arbitrarily add any new attributes or methods in each subclass. It's completely up to you. So we cannot say anything. They're simply incompatible. Okay? All right, so beyond the parents' expectations, no comparison. We just cannot compare. All right, guys, it's a very important table over here. Let me recap very quickly what you should really study when you actually revisit this table. Number one, whenever you declare some reference variable, pay attention to the type or static type you will declare the variable to be. Once you declare the static type, it determines the range of attributes and methods you may call upon the context objects. And this is just one example. And then remember about the different observations that we spoke about. You can rewatch the recording if necessary. All right, so these are very important. Are we okay? Okay, keep that in mind. And notice one thing here. When I was trying to figure out together with you about what we should fill in the table, did I ever make reference about a new keyword over here? I didn't. And that was intentional. What does that mean? That means whenever you want to determine something about expectation, what really goes after the new keyword over here, which we'll later refer to as dynamic type, they are not relevant. Okay? I'll make a quick notes over here, but we'll see more detail later. Think about the new here, the new here, new here. They are to do with the dynamic type. Dynamic types, but not relevant for the table. Okay? Good. Let me go back to see what else. Okay, that's the table over here. Okay, good. Now we are ready to talk about the two core concepts. I will give you, that's why I call intuition. I want you guys to understand the intuition right away so that we got tons of examples to go over for the coming lectures. All right? Let's take a look. First one. I want you to take a look at this fragment of code. We got line 1, 2, 3, 4, 5. Okay? We say students, resident students being the static type for S and RS. Okay? And we say RS does set premium rates, which is okay because resident students does have explicitly the set RS resident student does have the set premium rate, so that's okay. Now, line number 4 and line number 5. See what I'm doing here? I'm exploring different possibility. Either I will try to assign RS to S, or I'll try to assign S to RS. Stare at these two variable assignments for a moment. I'll give you guys 1 minute, and I want you guys to tell me, are they both valid? Are they both invalid? Or maybe one is valid, but the other one is not. If so, which one? Okay, I'll point to you. Give me a moment. It's a very important intuition you have to remember, and I'll try to give you something that hopefully, if you forgot about the rules later, beyond this course, you can still easily reproduce the reasoning yourself. I'll get there. And my hints to you, in order to determine whether each one of them is valid, you have to use the idea about expectation. Okay? Okay, I'll give everybody just 30 seconds. It's really important for you to think a little bit yourself because your first intuition may be right, may be wrong, and then I'll try to correct you if necessary. But we ought to know what the correct answer is as well. Okay? Yes, I'll go with you first.
So from the declaration, we can see that S is a type student and RS is a type resident student.
Mm-hmm.
And then below that, we can see that we're trying to basically assign to the S variable the address of where RS is. So I don't think that the first line is valid, but I think that the second line is valid.
if I heard you correctly, I'll start with this first. You are saying that this one here, I'll put it here. You're saying this one here is not valid, but this one is valid.
Yeah.
Okay, can you give a little bit quick explanation quickly, and then I'll see if anybody will agree or disagree.
Basically, from the expectations, we know that the student has X amount of expectations, and the resident student has some more expectations than that.
Okay.
So it's sort of like what we learned in past classes about like subclasses, and so it's a subset based. So
I see what you mean.
it's a subset of student, but student isn't a subset of resident
Got it.
student, so they can't match in that way.
Yeah, if you don't mind, let me just repeat what you're saying. I like this idea. Your name again? Savon. Savon said the following. Because we know S declared to be a student has fewer expectation. RS declared to be resident student has more expectation. How can you assign something more into something that's less? That should be invalid. That's his argument. Will everybody agree? I like that argument, which makes sense to me. Anybody will disagree? All right, I'm glad you guys agree. I can tell you that, remember this moment. This is wrong. All right? I was worried that you guys, if you choose the right answer, then I need to present a little bit differently. But I'm glad you chose the wrong answer. Okay? Guys, the answer goes like this. But I think the intuition I just repeated is really important. That's something you would like to avoid and clarify yourself why that's not a way to think about it. It turns out the answer goes like this. This is valid, but this is not valid. Okay? Now, that's why I want to give you intuition. And also, one thing you can see, I can tell you why it's tricky. In the exam or in the test, it will be given a very large inheritance hierarchy. And then I might simply declare maybe 5 different variables like this. I'll simply give you different assignments. You got to decide which one valid, which one invalid. If you don't really get your intuition clear, you just get confused. You will just guess, which is not right. Right? That's why I want to show you guys the intuition. Okay? Have you guys heard about something called proof by contradiction before? Okay. I'm not going to go very, very mathematical. I'll put it in a very intuitive way. Basically, proof by contradiction goes like this. If I want to prove that this is something that should be wrong or false, I assume it is okay, it is true. But somehow, based on this being true, it can lead to something disastrous. That means the original assumption must be false, and this should be invalid. That's the proof by contradiction I'm going to go with. I'm going to make it very intuitive. Okay? Let's go with this. The way I'm going to prove that this is wrong is by proof by contradiction. Okay, let's try that. This is something I really hope that you can really learn and remember beyond this course. If you ever have to face this kind of situation again, just remember that proof by contradiction and reproduce yourself. It takes only less than 1 minute to reproduce. All right, here we go. Let me say the following. Number 5, let's do the following assumption. Assume RS is assigned to S was valid. And everything else I'm going to discuss now is going to be based on that. What should we do? Let's do a little bit of visualization. Before what we had, let's visualize that very quickly. Okay? Line number 1, we simply got S pointing to a student's objects. And if you can remind yourself, we got name, courses, and number of courses as the attribute, right? We got name, courses, number of courses, and the value of them are not really relevant. Just remember they are there. There will be storage allocated for them. That'll be S. Of course, if you want, it's Stella. Just remember. Okay? And what about the second one? The second one will be RS. Oh, you know what? Let me just make it consistent with the color. So this will be green, let's say. Okay? Let's have another one. This one here will be RS. And then I have RS over here pointing to here. A resident student's object, which has wider expectation, right? Not only that we got name, courses, and number of courses, but also we got premium rates. Agree? Right? Be more precise. You can see this part here, shared or inherited from, oh, sorry, let me do it again. This part over here is shared or inherited from the parent class. This one here is only specific to resident students, okay? And we assume this was valid. What does it really mean? That means we're gonna let RS point to wherever S is pointing to. Agree? Okay. So that means executing the assignments points RS to a student objects. Meaning that RS, rather than pointing to over here, is now going to point to over here. That's step number one. Are we okay with this? Step number two. Let's go back to expectation. If RS is pointing to this object here, would there be any trouble of fulfilling the expectation we impose on RS based on its declared type? If you already see where I'm going, I think you're on the right track. Marcus.
Yeah, so because of the expectations, when we declare a resident student, we know that we can use set premium rate, but now if you do RS equal to S and you point it to the
Yes,
student object,
absolutely.
then you can't use set premium because there is no premium.
Absolutely, absolutely. Okay, good. So number one is over here, and number two. Okay, expectation on RS. We can say RS dot, right? And the only thing we need to worry about is about RS and its static type, which is resident students, which includes premium rate for sure, and also set premium rates, and all the others that's inherited. Okay? It can be RS, one of them. I'll just say one of them. Set premium rates. And let's say 1.25. So now, if I try to do that, that means RS over here, set premium rates. RS pointing to this object over here. Do I have any premium rate for me to set? No. So, crash. By assuming this was valid, we can easily lead to some crash. So that means Java compiler would consider this as invalid. All right? Guys, are we okay with this? Okay? That's kind of the most logical way I think of, we can argue for that. All right? And let me just say a little bit more. So we know that this one is invalid, right? So this means RS assigned to S should be invalid. All right, that's kind of the proof by contradiction I want to show to you. And how do we decide in general over here? Let me give a little bit look ahead. I'm going to give you the rule very soon. Whenever you have an assignment over here, if you got object 1 is assigned to object 2, all right? I'm going to give you the rule. Let's say, if you say, I'm going to make it very symbolic. Let's say class 1 and also class 2. That's how we declare the two objects. Right? Of course, you might do some initialization of the object if you want to, but that's not the point. Okay? How do we determine whether or not this is valid? You want to make sure after doing this particular assignment over here, object 1 will still be able to fulfill all the expectation imposed on C1, basically, right? You can always think about this particular example, but I'm going to write down the rule. To be valid, the static type of obj2 which is C2. Should be, here I'm going to say a very special case, which you can link back to the original case. Should be a subclass of the static type of object number 1. In this case, you can see object number 1 declared to be C1. Now, how can we apply this principle back to this example here? If you look at this, RS is assigned to S. What is the static type of S? Students. What is the static type of RS? Resident students. Now, is students a subclass of resident students? Is students a subclass of resident student? It is not, apparently not. So that's why it should be invalid. Otherwise, if you try to apply the same rule to here, it would be valid. This is the kind of checks you will have to do so intensively in the coming examples, all right? All right, that's about intuition. And the only thing I would like to highlight over here a little bit further. So here, a subclass will have to be relaxed a little bit, not necessarily just the class immediately below. In general, you can have multi-layer of the classes. That's something I will show to you, okay? So here, subclass, in general, we'll cover that very soon. It should be so-called descendant classes. I will explain what descendant classes really means later. Descendants classes. Okay, that's something we'll see later. Any question about the intuition here? Yes, please.
So after we reassign them to the different classes, for the variable S, if we try to do S dot set premium rate, we need a premium attribute to do that. So is that attribute just the default value whatever is
Good question. Good question. I like that. Okay, let me try to, if I understood you correctly, let's look at the line that's valid. Let me do this. I'll make a copy of this. Okay? Now, let me clear the proof by contradiction over here. Okay? And then we also got our original S and RS over here, let's say. Yeah, just bear with me. I'll clear this up. This one here, and this one here. Okay, we got S, we got RS over here. All right? And then let's now talk about line number 4. Line number 4 will be valid. Let's think about what's going to happen. Given that this is valid, that means by executing this assignment over here, we're going to let S point to wherever RS is pointing to. This is okay, all right? And I believe you were asking, what's going to happen if we try S dot set premium rates? Okay, very good, thank you. I like that question. It's really important. It looks possible because S is indeed pointing to a resident student object which has the premium rate. I agree. But is this even going to be valid? Yeah, go ahead. Exactly, very good. So what I need to point out over here is a very good thought. I'm going to say 2 things. Number 1, this method call here is not valid because the static type of S, which was declared to be the students, does not declare premium rates. Premium rates. You can think about the static type is actually students. So premium rate and set premium rates outside its expectation. If you try to do this, you wouldn't even be able to do it. That's number 1. Okay? Number two. We might find that Java compiler is so unflexible. S is indeed pointing to some resident student objects. We really want to set a premium rate for this object. Can we do it? Indeed, you can. But you will have to do something tricky, something additional. That's something you guys ran into when we talk about object equality. Do you remember what it was? Phase number 4. Yeah, we got object OBJ. We have to somehow do some massaging to make it, something a little bit more specialized, like a point V2. Typecasting, exactly. All right. Number 2, typecasting is possible. Can make this work. So I want you guys to, since I really like the question being asked at this level. So what you guys want to remember, let me recap. Whenever you're trying to make a method call, make it very simple to yourself. Don't be confused about what object is being pointed to. If you want to decide whether or not you will compile, only look at the static type for the context object. Always remember, students, in which case you just cannot call this. Number 1. Number 2, if you really, really want to call this method because you know the objects being pointed to at the moment can indeed support a premium rate. In that way, you as a programmer, you can overrule the decision by the compiler by using typecasting. I wouldn't write the syntax now. It might just confuse you further. But typecasting is something we'll discuss hopefully next Wednesday. Not yet. We'll get there. All right, good. If you're still following so far, that's a very good sign. Okay, the next one. That's about polymorphism, meaning that you can just do variable assignments over here, but you got to know which one should be valid. The next one is something called dynamic binding. Okay? It's more like a consequence of polymorphism. Okay? Let's see. I would say in order to do dynamic binding, you really have to draw a diagram to really keep track. Okay? Let's take a look. Let's say the following. Let's say we got a course, 2030, over here. And then we declare S to be a student. And let's make a note right away. You can see the students over here is the static type of S. Meaning that every time you want to do S dot, the range of attributes or methods that might be valid here is determined by the static type. Always remember. I'll write it down. So this means when you say S dot something over here, so this will be the expectation, which is determined by the static type. The static type of the context object, which is S. All right? Good. And we declare RS and RS over here. Right? And then we got resident students, we got non-resident student, and etc. Okay? And then we simply set, okay, but we got RS and RS. We got RS and so also NRS, different objects here. And then one will be Rachel, the other one will be Nancy. Doesn't matter, so but I'll just write it down. You can think about this is the Rachel objects, and this would be the Nancy objects. And every one of them is going to get a list of courses, right? I already draw the diagram so we can save some time. Before we do any variable assignment, before that, let's try to set their premium rates and also set discount rate. Number 1, little practice for you guys to think about. If I ask you to explain to me, should this line compile or not? How would you explain it? Would RS that set premium rate 1.25 be valid? What should we look at? Should we look at its static type or dynamic type? Only static type, right? RS declared to be resident students. Does resident students support either explicitly or implicitly set premium rates? Indeed, it does. So that's why it compiles, right? Always, one thing you want to get used to, whenever you see a line method call, always think about if that should compile, all right? So let me just continue, and then I'll get to the dynamic binding. So we got 1.25, so 1.25 over here. And also we got 0.75, which is discount rate. And also we register 2030 to both students. You can think about 2030 here and also 2030 over here. All good. Let's now focus on these two lines. Okay, these two lines. And as your little exercise, both of these are valid for the reason that we intuitively explain in here. Okay, I would suggest think a little bit more to yourself about why these two will just compile. Okay, but now I'm going to talk about something else. So you can think about dynamic binding built on top of polymorphism. What's going to happen is like this. After I say S is assigned to RS, I try to call S.getTuition. And then I try to reassign S to be NRS. And then I try to call S.getTuition again. So what you will see is we are calling the same method, getTuition over here, with just the same context objects. If you try to recall in the review lecture, in the context where we don't have any inheritance, whenever we are trying to call the same method, if the context object is the same, the result should be the same. But now, with inheritance added to the context, no, not in general, not anymore, because of dynamic binding. All right? So now let's try to think. When we try to call this getTuition here at this point, and when we try to call S.getTuition at this point, are we really having the same conditions to consider? Was something actually changed in between? That's the question. All right, go ahead.
Since there are some student residents who have different traits, tuition
Also be different. Okay, that's good. To be more formal, we want to say at this point, when we call getTuition, it has a different dynamic type as when we try to say S.getTuition at this point. What do I mean? Let's take a look. Let's start with here. If I say S is pointing to wherever R is pointing to, so S was declared over here, is pointing to wherever RS is pointing to. At this point, after this line over here, dynamic type of S becomes resident students. Let me say that again. After executing this assignment here, S is now pointing to an object. You can see from the title of the box is resident students. So that means its dynamic type has been changed to resident students. All right, number one. Number two, when you try to call this getTuition over here, at this point, it depends on this, S. That means when you say S.getTuition, it is going to apply the premium rates because the dynamic type supports the premium rate, number one, okay? So that means this getTuition over here is going to be apply the premium rates. More precisely, it is this getTuition overridden version that's being called. Are we okay with this so far? Dynamic binding all depends on how you trace the objects being reassigned to one another. Ferris, you may have a question, right? Go ahead. We don't need to. Let's see why. Ferris' question was, is it really within the expectation of S to call getTuition? Indeed, it is. Okay, S, first of all, has a static type students. It does have the getTuition. Ferris, you know what? I'm glad you asked this question. Let me say a little bit more. At this point, how many versions of getTuition do we have in the inheritance? How many versions? 3, I agree. Thank you. Number 1 here, base amount. Number 2 here, overridden in the resident students. Number 3 here, overridden in the non-resident students. We've got 3 versions. Which version will be called depends on the dynamic type of the context objects when you make the method call. Let me show you. In this case, when we say S.getTuition, in order to know which version is going to be called, we need to look at what S is pointing to currently. It is pointing to here with the dynamic type resident students. That means it's going to invoke the version with the premium rate. Marcus.
I just have a question. So how do you know when to decide if you should be looking at the dynamic types or the static types?
Very good. I believe I have some summary maybe a little bit later towards the end. Good question. Here's the principle, right? There might be some exceptions sometimes, which I'll mention, but I'll say in principle. If your goal is to decide about whether a line should compile. If that's your question, look at static type. Meaning that you only look at where the variables are declared, number one. Number two, when should you look at the dynamic type? It's about which version of the method. Well, think about the runtime behavior, like which method version will be invoked. Should be invoked.
So that means that when you like apply, you have overwritten methods.
Yes, yes, true. In some cases, maybe in the subclasses, you simply inherit verbatim from the parent class without overriding it, in which case you only got one version. But conceptually, there could be multiple versions. Yeah, look at dynamic type. This is a very important principle which I'll keep emphasizing, but we'll get there. Okay, just a very quick principle for you. Okay, let's move on. That's about how we execute this line here. Let's say we try the next one, which will be here. So now dynamic type is going to change. By the way, the name static versus dynamic is actually quite accurate. Static means once it's declared, it cannot be changed ever. Dynamic means it can change always, all the time, as long as you want to. All right, that's why tracing is also very important. Let's now try to look at this line here, okay? S is assigned to NRS. How is it going to change? So I'm going to use a different color here. How about blue? Blue is not good, it's being used. How about purple? It's being just used. How about, sorry. How about this one? This one, I'm pretty sure it's fine. Let's say we try to execute this line here. Okay? This one here, S is assigned to NRS. That means S, rather than pointing to over here, it's going to point to wherever NRS is pointing to. That's the change. And then we try to look at get tuition over here with the context object the same, which is S. Now, things change. More precisely, dynamic type of S. You can think about this particular assignment here changes the dynamic type of S. S used to be pointing to here with the dynamic type resident students. But now we redirect that into another object here with a new dynamic type, non-resident student. So we change from here to here. That's how you should see it. Okay? Dynamic type of S from resident students to non-resident students. So when we try to call this method over here, get tuition, the same method, so now dynamic type of S is NRS. You can see here, RS versus NRS. Different dynamic type is going to cause potentially different version of the method being called. In this case, when we try to invoke this line here, which version is going to be called? 1, 2, or 3? Would you 3, right? Because dynamic type is now here. So version number 3. That's going to call that version there with the discount rate. That's really the simplest scenario I can think of for dynamic binding. Later on, we're going to have the fun of incorporating this into array, but we'll get there a little bit later. But I want you guys to really be sure. We still have some time today. I'm going to go over a little bit more. Before Monday, we're going to dive into many more examples to really check compilation, also check for runtime behavior. I'll get to you. Just give me a moment. And then before that, I would suggest revisit these two intuitions very carefully. That's going to help you a lot, rather than just getting lost. Everything we're going to talk about for the rest of the inheritance lecture depends on these two intuitions a lot. If you really got 100% of the intuition, most likely you'll be fine. Okay? I'll take a question and I'll make a recap, and then we can move on. Go ahead.
It's more of a hypothetical question, but if, for example, get tuition
Mm-hmm.
and V2 subclasses somehow used a method that could not be used on a student type variable, then I'm assuming the get tuition method wouldn't work, right? No, so from the last example we saw, we set S to the RS.
Mm-hmm.
We weren't able to use the method
Okay.
because the static type didn't have that method. So if the new get tuition, like if we use get tuition from resident student,
Okay.
and that method somehow used a method, for example, get premium
I see what you mean.
on the static type student,
I see what you mean.
I'm assuming that would work.
That would be fine. Okay. I kind of see what you mean. Let me try to reproduce it. Okay. I think it's also worth discussing quickly. Okay. Let me just make it clean for everybody over here. Okay. So let's say we further modify a little bit here. So for the, let's say set premium rate, we know that it's only available in the resident student class. We know that, right? Okay, you're basically saying inside this method, set premium rate, whatever. You're saying maybe at some point you're trying to invoke another method. Okay, let's say, let me call it M. So where do you want M to be?
Well, if M, for example, was a method, or it wouldn't be within premium rate, sorry, it would be within like get tuition.
Get tuition? Okay, sure. Let me do that.
That all three can invoke.
Okay, let me give it a try. Okay, I see what you mean.
So if we, for example, get tuition invoke premium rate.
Okay, sure. Okay, how about this? I know what you mean. Yeah, that's fine. So let's say we got our get tuition method here. That's the overridden version with no parameter, of course. Let's say now at some point we want to invoke, did you say set premium rate?
Sure.
Let's say, okay, good. So we might say this dot set premium rate. I know I see where your confusion might be. Let's take a look. Some amount over here. All right, guys, let me see. Let me see the starting context over here. Inside the overridden version of the get tuition, we try to call a helper method set premium rate that's only available in the subclass over here. That's what we're doing. Okay? I think the conclusion comes from here. If you take a look at here, S over here, and also we say S is RS. Okay? Let's try. So RS, according to here, is pointing to some resident students object, let's say. Let me put it down. Resident student object with all the attributes and also with the premium rates, some value over here. And then after executing this assignment over here, which we know is valid, S is actually going to point to this object over here. Okay, now, good, I see. In order to actually call this method over here, get tuition, we know that at the moment, dynamic type of S is resident students, meaning that we're going to call this version. Version in resident version of get tuition in resident student will be invoked. Right, number one. And then number two, when we invoke this particular version and when we do this one here, okay, you're wondering, would it be as if we say S dot set premium rates, which we know is valid? Okay, very good question. The answer is this will be okay because you didn't really write it explicitly yourself as a line. This is simply implicitly called by the Java compiler. So that's actually fine, okay? So you can think about, it's a little bit more advanced example, which I like. Okay, this one here. This will implicitly call the set premium rates on a resident student's objects. The way you can think about this is, S is simply just the context object where you are trying to call the method, but the actual object being called is actually over here. So when you actually execute this line, you will still try to set a premium rate just for this object here. Okay, that's one thing. Okay, so this is okay. On the other hand, let me conclude this example here. On the other hand, and guys, I have a nice analogy for you. Bear with me. Okay, on the other hand, if you write S dot set premium rates explicitly. That wouldn't work. You can let Java call the set premium rates implicitly on the objects behind the scene. That's okay. But if you write s.set premium rates, we follow the same rule about expectation, so that one wouldn't work. I'll take a question, and then I'll do the analogy. Go ahead.
Sorry. So this dot set premium rate is at the tuition. So does this imply that you call it the residence rate?
Okay, good. You can think about in this case, the main confusion was this supposedly should be S. So that'll be S.set premium rate. This is kind of implicit. But you want to think about, at this point, since you didn't write that line explicitly yourself, it just happened that in the execution flow. In that way, this one here is really just calling this method here on this object. So that's okay, implicitly. But you cannot write this line explicitly yourself. Yeah. Okay, let me give you an analogy. I hope that will help. Do you guys remember this example here? Remember point V1, point V2, right? Point V1, and let's say point P1 would be something. And also we got point V2, a different type, P2. Do you remember when we say assert equals and P1 and P2 versus P1 equals P2? This, I remember, was in your written test too, right? Is this going to compile? This one actually is going to compile, right? Remember, that's okay if you got it wrong, that means you got to make sure you review, okay? And if you remember, it's going to be boiled down into P1 dot equals P2, first of all, right? And then P1 was declared as point V1. Actually, to be more precise, because of dynamic binding, it depends on this type. But let's not worry too much. This one here is going to invoke the version in objects in the object class, which means it's going to be boiled down into P1 equals P2 implicitly. But if you try to write P1 equals P2 explicitly, you're going to get compilation error. Right? That's the analogy here. So here, if you actually try to execute this implicitly, set premium rate on S, that's okay, because it happened to be the dynamic type. On the other hand, if you actually try to write this down explicitly, because set premium rate is outside the expectation of S, which was declared as student, that's not good. That's the analogy. All right? So guys, if you already understood these two pretty well from the previous lecture, I think the analogy might help. If you're confused, look at both. That will definitely help your exam. All right? Both are important. Okay. But I like the question a lot. Very good. Let me recap very quickly. And then we got about 4 minutes. All right? And then I will see what I can do. Right. So about dynamic binding, this is what you should remember. You want to remember the way you make dynamic binding, trace a dynamic binding is by tracing how the reference variable is pointing to which object. Could be this one here, could be this one here. At the point you're trying to make the method call, you really have to look at what is the dynamic type for the context object. Could be here or could be here. Once you determine the dynamic type, the version of the method, in this case get tuition, will correspond to that particular version over there. That's why you got to remember. Okay, I got about 4 minutes. Let's see what we can do. Okay, but it's a nice break after another 3 minutes because on Monday you have time to really revisit these two: intuition, expectation, and etc. And we'll get to the more systematic way of doing things. That's what we'll do. And then hopefully we can get to casting a little bit. All right, polymorphism, dynamic binding. These are the two intuition. And let me say one more thing quickly, and then we're done. Okay? In general, inheritance hierarchy can be more complicated. What we had was we only got, so far we got students underneath it, we got resident student, we got non-resident student. It's not realistic. More realistically, you can get multi-level of inheritance. Under student, let's say we might get domestic or foreign. Under domestic, we might get domestic resident and domestic non-resident, and etc. All right? That's one example here. And for the reflection here, I'll mention that briefly maybe in the beginning on Monday. But I want you guys to also look at this hierarchy here. This will be another running example we will use for the rest of the inheritance lecture. We got 2 minutes, just enough for me to go over this hierarchy with you. Make sure you get familiar with it, which I will assume for Monday. Okay? We got a hierarchy of the smartphone. And I'm sorry, the models for the phones are not exactly up to date. I do know they have released new models for the phone, but forgive me, all right? But you'll get the idea. At the top level, we got something called smartphone, superclass. And at this level, we define 2 basic methods, meaning that every smartphone, you should be able to dial and surf the web, all right? And then you got either iOS or Android, depending on the OS, right? Under iOS, you got either iPhone SE or iPhone 13 Pro. And what's so special about it? You can take a look. Here, for dial, it will just be inherited verbatim to iOS. But for the surf web, maybe we'll try to override it in the case of iOS. You can think about whenever you want to do surf web in iOS, you're going to use maybe Safari. Whereas, if you want to do surf web on Android, maybe you will use Firefox by default, let's say. May not be so true, but let's say. You can also define some new methods in iOS. Let's say we got FaceTime. And you also can define another Android-specific new method called Skype, let's say. Okay? And what's more? Under iOS, we got iPhone SE, we got iPhone 13 Pro. For iPhone 13 Pro, we introduced a very new feature here called Quick Take. Okay? Don't worry too much about what exactly you will do, but it's a new method. Quickly, under Android, we got even more hierarchy here. Either it can be manufactured by Huawei, can be manufactured by Samsung, for example. Under Huawei, you got these 2 models. Under Samsung, you got these 2 models as well. What's this method here? It's a new method that's only introduced at the Samsung level. So the side sync is not available in Android in general. It's only available to Samsung and also its subclasses. One more point. You can see zoomage over here is a new method we introduced in this particular model only. It's not available here in its sibling. It's also not available in its parent class or parent-parent class. So this is kind of the class hierarchy you will be given in the test and in the exam. I'll give you guys practice question, don't worry. But before Monday, that's what you should do. I know I'm over time, just bear with me 30 seconds. This is what you should do, I will advise. Of course, take advantage of the extra week to get prepared better for your programming test too. I'll be very happy for you if you do better next Tuesday. Number 1. Number 2, you want to revisit what we said today, especially about the intuition of the polymorphism and also dynamic binding. And also revisit this table here very carefully, especially about the 3 observations I said. We're going to generalize them even further on Monday. And finally, you want to make sure, let me see anything else. Look at the hierarchy here and make sure you get yourself familiar with the smartphone hierarchy. We're going to refer to it also very often. Awesome. Thank you so much. I'll see you on Monday. And if you got any trouble, let me know.